Basic complete search. What is it? Well, basic complete search essentially just means brute force. And what does brute force mean in the context of programming? Well, it means trial possibilities. That's why it's called complete search. So we're going to completely search every single possibility. And this works well when we have an input size that is small. Yeah, like that's basically what complete search is. Basic complete search. Let's do an example without coding first. So, say we're given an array, and we want to find two numbers that add up to 10. Okay, and we're given the array 1, 4, 7, and 3. Okay, so how would we go about this with the basic complete search? Well, we would first add up 1 and 4, and that would give us 5. Then we would add up 1 and 7, that would give us 8. Then 1 and 3, well, you get the idea, 1 and 3, and then we get 4. But then after that, since we know all the things that 1 add up to, we're going to try to do literally every single possible combination of these two numbers in this array, and add them up until we get two numbers that add up to 10. So we would go like we would do 1 plus 4, 1 plus 7, 1 plus 3, then 4 plus 7, 4 plus 3, and then 7 plus 3, until we get a number that adds up to 10. And when we do that, we'll see 7 plus 3 adds up to 10, and we'll print that out as a solution. Okay. And we would use this using this solution specifically. We would use for loops for this, or we could use while loops, but we would use for loops in this one. That'll be easier. Okay. And I've chosen a problem statement for this. So let's say we're given n integers, and n is less than or equal to 100. We need to find the maximum sum of two integers in an array. Okay, I've already coded this problem, and here's the solution. Let me explain it for you. So don't worry about these two lines of code right now. Those are just purely for the input speed, output speed. Here's the actual program, and here's the actual basic complete search algorithm. And so let me break this down for you. So this is where I'm initializing n and taking the input of n, and I'm initializing the vector a of n. So vector a has n items, and this for loop here is reading all of the items from n into the vector a of n. Okay, this line of code is basically saying the best value currently the best value currently is int min. And what is int min? Well, int min is a predefined integer that's already predefined in C++, and that's the lowest possible integer. So it's just some value, I think negative 2 million. That's basically what int min means. And I'm saying best, the current best is int min. Okay, this is where we get to the actual algorithm. So we use two for loops here. The reason is, well, I'm going to get to it. So for loop here, what this does is it reads, or no, it doesn't read, sorry. It says I equals to 0, and j is I plus 1, and this is because we want to get the index value of, say we have an example array 3, 9, 7, and 2. We want to get the index value of 3 and then 9. So say we have I equals 0, then we can say a of I, which is 3, plus a of j, which is 9, right? So we have a of I, 0 plus a of j, and that's why I did uh I plus 1, j equals I plus 1, so we don't get 3 plus 3, because we need two distinct numbers. Let me add this here. Okay, so then the second for loop basically does the same thing as the first one, but it reads the second number, and I'm gonna walk through this right now without running the code. So I equals to 0, j equals to 1, and the best is equal to the maximum value of the current best, or this one, which is which is 3 plus 9, and that is 12. So the lowest possible is negative 2 billion something, and just 12. So out of the maximums, well, it's obviously this one, 12. And so the new best equals to 12. Now we're gonna do this again. So rerun this for loop and say 3 plus 7. Well, we have 12 plus 12 comma 3 plus 7, which is 10, and 12, what is the max value for this, 12 or 10? Well, 12. So we're going to keep 12 and run this loop again, and essentially what it's going to do is 3 plus 9, 3 plus 7, 3 plus 2, and then when j finishes its iteration, it goes back to this for loop, and now I becomes 9. So now when I becomes 9, it's going to go from, well, it's gonna go 9 plus 7, 9 plus 2, then that finishes iterating, and then it goes 7 plus 2, and then 2, and that's it, and it ends. And so when you run this, okay, I'll say my array is 4, and 3, 9, 7, and 2, you get 16, and this is because, well, 9 plus 7 equals 16, so it works, but it'll get slow once you have a larger input, right? Because this is O of n squared, because I have two for loops here. And we'll actually realize if I optimize this solution, I could get something like this, which is, the solution for this is, I could just sort this array. So I would get 2, 3, 7, and 9. And then when you realize sorted the array, you'll realize that the greatest numbers would always be at the end. So if you want to find the sum of two distinct integers, you would just need the last two numbers. And so this completely makes these two for loops useless, because you don't need to loop through any numbers. And so this is one case of optimization, and one case that you could just skip this algorithm and just use something like this. But there's many other use cases for the basic complete search, and this is just one way I can optimize this solution. And let me explain how this optimization works, basically. Well, I've kind of explained it here. But you sort the array first, and then when you sort the array, the last two numbers are the greatest numbers. And you can just add up the last number plus the second to last number. So what I've done here, so I've taken an input, created an A vector of n items, read all the items into vector A, and then sorted it, and then I've basically said the best variable equals to the last item, plus the second to last item, and that's our greatest value. And if you run this again, let's see, we have 3, 9, 7, and 2, and we get 16. Yep, that's it.